Hello everybody, welcome to session 1 of chapter force. This is second chapter uh, of physics, and the objective of today's class is to define force and explain its effects, and next is to define inertia and explain its types. Force. So force we always apply from the outside. That is why force is called external agent. And when you apply the force on a body which is in rest, then it comes in motion. That means it can change the state of body from rest to motion. And similarly, if a body is moving and if we apply the force from opposite direction, then that moving body will come in rest. That is why force is defined as an external agent that changes state of body from rest to motion or vice versa. And SI unit of force is Newton and CGS unit is dyne, and the relation between Newton and dyne is 1 Newton equal to 10 to the power 5 dyne. And force is vector quantity because it has magnitude as well as direction. Force has many effects, like just before we discuss in definition also, the force can change state of body from rest to motion or vice versa. It can change shape and size of body. Means by using the effect of the by using the force, we can change the shape of body and we can change the size of body. And next is we can push or pull the body. These are the effects of force. Inertia. So inertia, it is the property of body which makes the body to stay in its own state or position. Suppose one object is at rest, then that body always tends to be in rest. And if the body is in motion, then that body has tendency to always be in motion. Example, if you check in space, all the heavenly bodies, they are in motion. So they always remain in motion. And this kind of property of the body is called inertia. But if we do same activity here on the earth, the moving body will come to rest. The reason is that because of friction, the opposite force. But if we kick the football in frictionless ground, then that football will always keep on rolling, because the property of body is always to remain in its own state. And this property is called inertia. So that's why inertia is defined as the tendency of a body to remain in its own state. Yeah, state means it could be rest also and motion also. Until when it will remain in its own state unless an external force is applied. That means that body will change the state only when you apply the force from outside. Till we do not apply the force, the body will always tend to remain in its own position, and that very tendency is called inertia. In simple language, what we can say is everybody in this universe, that body wants to be in own state. If it is in rest, it will remain in rest. If it is in motion, it will always remain in motion unless an external force is applied. And this tendency of the body is known as inertia. And it depends on mass of body. Means, like here, for example, here I have drawn two sphere, small sphere and big sphere. So we can see here this small sphere has small mass, and this big sphere has big mass. So right now it is just hanging here. So right now they have state of rest. So since they are in rest, so they have inertia of rest because they want to be in rest. So when you apply the force, then of course it will change the state from rest to motion. But my question for you, whenever you push them, then which sphere will come in motion easily? Of course, the small sphere. For this sphere, it is very difficult. You have to apply more force to bring in motion. Why? Because it has more inertia of rest. Since it has more tendency to be in rest, we have to apply more force to bring in motion. But here, it has less tendency to be at rest. That's why easily you can bring them in motion. So here, who has more tendency to be at rest? The biggest sphere. Why? Because it has bigger mass. So since it has bigger mass, it has more inertia. That's why it wants to be at rest more than this sphere. That's why we have to apply more force here to bring it in motion. So here, what you can see is more mass, more inertia, less mass, less inertia. Means the relationship between inertia and mass is similar. More mass, more inertia, less mass, less inertia. Means relation is same. And such relation is called directly proportional. That's why you can see inertia body is directly proportional to mass of body. In symbolic form, I is inertia is directly proportional to mass of body. Means more mass, more inertia, less mass, less inertia. Or here, let's think another way. Suppose it is moving to and fro. Both spheres they are moving to and fro. That means they are in motion. And when they are in motion, they have inertia of motion. And if you want to stop them, where do we have to apply more force? Of course, bigger sphere. Why? Because it has more inertia motion, means it tends to be in motion more than this sphere. So to stop it, that is why we have to apply more force. That means since it has more mass, more inertia, less mass, less inertia. So between inertia and mass, we can see here they have similar relation. That's why this relation is called directly proportional. It is of two types, inertia rest and inertia motion, which we'll be discussing in next slide in detail. So here is one question you can see, which has more inertia, a cricket ball or rubber ball of the same size? Why? So there are two ball, one is cricket ball and rubber ball, and question is asking which has more inertia. So already we said inertia depends on mass of body. So between cricket ball and rubber ball, of course cricket ball has more mass. If more mass, then more inertia. That means between cricket ball and rubber ball, of course cricket ball has more mass, so it will have more inertia. So what will be the answer? Cricket ball has more inertia because it has more mass. Now let's discuss about inertia of rest. As I told you before, everybody in this universe, they want to be in their own position. Like here, a body is at rest. And if the body is at rest, that body wants to be in rest all the time. And that tendency of the body is called inertia of rest. So let's check the definition. Inertia of rest is defined as the tendency of body to be at rest. Till when? Unless an external force is applied. And it is found where? In all bodies which are found at rest. Whatever the body, if it is at rest, then that body has inertia of rest. Why? Because that body tends to be at rest. So here is one example. When carpet is hit by a stick, what you see? You can see dust falling down. Why? So here carpet is at rest. When the carpet is at rest, then naturally the dust which is present inside the carpet also is in rest. That means they have inertia of rest. That means they want to be at rest. But what you do, you have hit by the stick. So when you hit by a stick, then it comes in motion. But the dust doesn't want to come in motion. It wants to be at rest because it has inertia of rest. That is why what does the dust do? It falls down and again comes to the rest. That's why its answer here. See, as carpet is in rest, dust has inertia of rest, due to which it tends to remain in rest. Hence, what does the dust do? Dust falls down and comes to rest when carpet is hit by a stick. Inertia motion. All the moving body, have inertia motion. So inertia motion is defined as tendency of body to be in motion unless external forces are applied. So all the moving body has inertia motion means moving body tends to be in motion unless external forces are applied. And that very tendency is called inertia motion. So here one example I want to discuss. You know that your fan is moving, and whenever you do switch off, what happens? The blades of fan still move. Why? This is the question. Though you have already switched off, but the blades of fan, it is still moving. Now here the fan is moving means all the, as we said before, all the moving body has got inertia motion means the fan also has inertia motion. That means the blades of fan wants to be in motion. But what you have done, you have already done switch off. So the blade cannot, like does not get any energy to move. But since it was in inertia motion, so it wants to be in motion. That is why if you make switch off, then also the blade of fan will still move. That's why answer C. As blade of fan was in motion, it had inertia motion, due to which blades of fan tends to remain in motion. Hence, blades of fan still move though switch is off. Here, the blades of fan had inertia motion. Because of that, it tends to be in motion. That is why though switch is off, it is still continue to move. Now this is your assignment uh, from this video. So there are 10 questions, and all these 10 questions are designed from this discussion only. Like see, a bicycle runs from for some time even after the rider stops pedaling it. Why? You have seen around, if you ride a bicycle, even you stop pedaling, but still the bicycle will run. What is the reason? Okay, very simple answer. Since bicycle was running means because bicycle has inertia motion. That means this bicycle tends to be in motion. That is why even you stop pedaling, the bicycle still runs for some time. Next, passengers of moving bus jog forward when it is stopped suddenly. Why? So you might have traveled by bus. So in moving bus, if the driver applies brake suddenly, what it happens? All the passengers will moved, jog forward. What is the reason? So since the bus is moving, the passengers are also in moving. That means passengers they have inertia motion. Means passengers want to be in motion, but bus has already stopped. So because of that, passengers since they have inertia motion, they tend to be in motion. That's why they move forward. Next, just opposite. Suppose your bus is at rest, and if the driver suddenly move the bus, what happens to passengers? They jog backward. What is the reason? Since bus is at rest, the passengers in bus also has inertia rest. I mean, these passengers they want to be at rest. But what happened? The bus has moved already. And since the bus has moved already, passengers they cannot be rest. But they want to be at rest. That's why what they do, they move, they jog backward. A man jumping out of moving train or bus falls with his head forward. Why? So you might have seen if a person jump from the moving bus, what happens to him? His head will fall forward and he will fall down. The reason is since he is jumping from the moving bus, so the man has inertia motion. So his upper body wants to be in motion, but when he jump on the ground, his lower part of body has already come to rest. But because of inertia motion, the upper part of body of this man wants to be in motion. That's why his head forward and fall down. The fruit fall down when branches of fruit trees are shaken. It is same like carpet that we discussed before. The fruit, it is in inertia of rest. So this fruit want to be at rest. But what you did, you have moved the branches of fruit tree. So that's why what does the fruit do? It falls down and again comes to rest. Why an athlete runs some distance before taking off a long jump? So athlete runs. So when he runs, then he gains inertia of motion. And because of that, what he can do, he can jump a bit long. So that is why the athlete runs some distance before taking up a long jump. An aeroplane runs in a runway before taking flight. You have seen in airport, whenever you know aeroplane is about to take flight, what does it do? It runs for a while in a runway. Why it's so? Same answer like 6. When aeroplane runs in a runway, it gains inertia motion, and because of inertia motion, it can easily take the flight. Here, when an aeroplane lands, it runs for a while in a runway. Why? So when the aeroplane lands in a runway, it doesn't stop immediately. You have seen it. The plane will run for a while in a runway and then finally it comes to rest. The reason is aeroplane was in motion, so it has inertia of motion. So because of that, it wants to be in motion. That's why it doesn't come to rest immediately. That is why it runs for a while in a runway. A running athlete cannot run immediately. Cannot, sorry, stop. Okay, this question is wrong. Cannot stop immediately. Okay, this has to be changed. So you might have seen a running athlete. Whenever a running athlete has to stop, then he cannot stop immediately. He has to run for a while and then only he can stop. Why? Answer is same like question number 8. So whenever athlete runs, then he has inertia motion. So his body wants to be in motion. That's why even athlete wants to stop, he cannot stop immediately. When a postcard kept over glass is pulled suddenly, coin falls down in a glass only. Why? So this experiment you can do in your home only. What to do is you take one postcard and over the postcard keep the coin. And this postcard along with the coin, if you keep above the glass and if you suddenly push the postcard, what happens is only the postcard will move but the coin will not move. Coin will fall on the glass only. What is the reason? Because whenever you pull the postcard, the coin has inertia of rest. And because of inertia of rest, the coin tends to be in rest only. That is why, though you have pulled the postcard suddenly, coin will not move because of inertia of rest and it falls down in the glass only. So this much for today, and I'll give you a session 2 of chapter 4 very soon. Thank you.